Given a function written in equation form that includes a fraction, we want to find the domain. Step 1, we need to find the input values. Step number 2, we identify any restrictions on the input. If there is a denominator in the function's formula, we're going to set the denominator equal to 0 and solve for x. If the function's formula contains an even root, we're going to set the radicand greater than or equal to 0 and then solve. Step 3, we write the domain in interval form, making sure to exclude any restricted values from the domain. Now for example 3, we want to be able to find a domain of a function involving a denominator. So find a domain of the function f of x, which is equal to x plus 1 divided by 2 minus x. Now whenever we have a variable in a denominator, we want to include only values of the input that do not force the denominator to be 0. So the numerator is not really what we need to worry about, because what makes this undefined is the denominator being 0. So we need to focus on a denominator. So we will set the denominator equal to 0 and solve for x, so we can figure out what would x be to make the denominator 0. So we have 2 minus x is equal to 0, and then we're going to solve this equation. So we subtract 2 to both sides, divide both sides by -1, and now x is equal to 2. Now let's plug that 2 back into the function. Well, 2 minus 2 gives you 0, which means that that 2 is the only number that you can plug in for x that's going to make this function undefined. So in part 2, we will exclude 2 from the domain, and so the answers are all real numbers where x is less than 2 or x is greater than 2, because we're excluding 2. In figure 4, we can use a symbol known as the union, U, to combine the two sets. And so the interval notation we're going to write as the following solution. So I want you to look here. It's really important to just make sure that you draw what the number line would look like. It gives you a visual representation of what the interval notation would look like. So if you take a look here, we have our value of 2. Okay, and we have to exclude 2. But what we can include are all the values from -infinity to 2, which means x is less than 2, but we can't include 2. So that's the first part of the interval notation. Okay, and then we have our union symbol. And then the next part is all the values that are greater than 2. So all the values that are greater than 2 are going to go from 2 to +infinity, or x is greater than 2. And so that is represented by this interval here. So we have parentheses 2, infinity. So therefore, this is going to represent our interval notation. So you just have to, when you graph it, you can just pull that data or that information from the graph, starting from -infinity, going to 2 with a parenthesis, and then union, starting at 2, going to +infinity.